Hello, everyone. Welcome to this talk on embedding security from code to cloud. Yeah, the main idea behind this talk is to understand what are the different security checkpoints we can add as part of a software development lifecycle so that we can ship secure infrastructure and code iteratively. We will look at some of the processes and some of the tools that are available that can help us ship this secure code. Before we deep dive, a little bit about myself. My name is Siri Varma. I'm currently a software okay. I'm currently a software engineer at Microsoft working with Azure. And previous to this gig, I was working with Oracle in their observability division. And apart from that, I'm a freelance contributor and love to hike as well. Now, coming to the talk itself, we all know that as part of our software development cycle, there are mainly three stages. First is your development, where you end up designing your feature, writing code, and then putting it up for code reviews. Once that is done, you end up building your code, which involves building artifacts and then writing unit and integration tests and then running them. Finally, you end up shipping the code, meaning running it in production and making it available for customers. Now, different aspects of this have different security checkpoints. So let's start with development. Here, as part of your design phase, once you complete your initial design with your team, you might also have a threat modeling or a security review with your team or with the security team itself. Then you end up running some static code analysis on your results to make sure that you avoid any common misconfigurations. So let's look at threat modeling into a bit more detail. So now that you have completed your development, it is time to do a security review. Now, either you can do it within your team, or you might have a separate security team that is handling it. The main intention behind threat modeling is to identify and mitigate any potential risks that your architecture might come under. Now, OWASP specific common is a popular open source community, and what they recommend here is using the SREday approach. Now let's look at that in a bit more depth. What we are seeing is a threat model diagram here. And as part of this diagram, this is done in the threat modeling tool. And I have my architecture here. So first I have a browser, then I have an API, and then I have some infrastructure pieces here, and then I have a processor, another application that is running. Now, keeping the SREday approach in mind, let's look at how we can identify and mitigate threats here. So because I have an API which authenticates and authorizes with the JWT token, what might end up happening is the clients that are talking to it, there might be an intermediary in between that could end up spoofing it. So basically listening to the traffic and acquire the JWT token and use that for the API authentication or authorization. So that is a threat we have identified. Now, one possible mitigation that we also have in mind is maybe using HTTPS, because HTTPS traffic is encrypted. Of course, getting that token becomes tricky. Apart from that, your token itself might have an expiry time, which might further mitigate the problem, because if it expires within 2 or 3 minutes, again, the token becomes invalidated and the attacker might have to again get a fresh token. So that is one possible mitigation. Now, if you see there's an API, but what if somebody ends up sending a bulk of requests and doing a DDoS on it? That might be a possibility. Now, because I don't have a gateway or an Azure friend door in front of it, I am susceptible to this kind of attack. So the action item that is coming out of this is, hey, I might need a gateway or a friend door that can actually protect my API. So that is what is your DOS. Now, because this API is reading from a database, what might end up happening is, does the user have permissions to read the data? Or is he reading someone else's data? For example, let's say you have bank transactions. You, of course, don't want your bank transactions to be exposed somewhere else. So that is where tenant isolations are required. And that might be one mitigation you might have already deployed on your service. That is nothing but information disclosure. Now, because we have an object storage bucket here, somebody can and might end up tampering the objects in that. So, in order to catch that, do I have proper audit logs? So, if you do, very good. And then once the audit, having audit logs only is not enough, because with a repudiation attack, what might end up happening is an attacker might do an operation but later deny doing it. So, does your audit log also have information about who did it, what is the action that has been performed, and from where it has performed? Does it have all that information? So, the main intention of this threat model diagram is to capture all this information. And in case if there are any missing infrastructure capabilities, you end up adding them. Nice. Now we are done with the threat modeling. The next thing, what happens is we end up writing code. Now, as we write code, we also want to avoid common misconfigurations. So for this, there are a lot of static analyzers that are available. For example, .NET has Roslyn, Java has checkstyle, and there are a lot of these analyzers available that you want to accommodate so that any of these misconfigurations can be found before you even commit the code. So what we will look at is one such tool. So I have a Terraform, and as part of this Terraform, I am trying to create a bucket. And with the popular example of putting the bucket, having the bucket read access is a problem. So now what I end up doing is I also run a static analysis tool on this, which is called, here you go. I end up running a static analysis tool on this, which is called, in this case, I'm using the open source tool Checkov. And what ends up happening is it goes through the Terraform configuration you have and identifies any vulnerabilities that are available. So depending upon the checks, it either passes them or fails them. So in this case, because I have a public read access, this check has failed. Nice. Now we have also completed the static analysis. Next, what we have is code reviews. CNCF has written a security white paper, and as part of that, what they recommend is at least having 2 code reviewers as part of your pull requests. And I know we have mostly incorporated this kind of style, but this is also what CNCF recommends. And also there are a bunch of AI generated code reviews right now that can help you debug or analyze these kinds of misconfigurations. Great. Now we ended up putting out a first pull request and merging to main. The next process involves distribution. So as part of distribution, there are again 3 more checkpoints. The reason I have static analysis again here is, as part of your development, it is not mandatory that you run it, but as part of your build pipeline, you can definitely enforce this. And the static analysis that happens as part of your distribution also does more than just what happens on your dev box, because it runs secret analysis, and it also performs other critical checks required. Then what we have is, because we run cloud workloads and most of our cloud workloads are Docker containers, we create these containers from Docker images, which can be vulnerable. So it is important that we also scan these images. And then if you have Kubernetes workloads, you end up having manifests as per Kubernetes manifest, which can have critical misconfigurations as well. So you, as part of your build pipeline, you want to make sure that these kinds of configurations are scanned before you go to production. Finally, there is signing. So the artifacts that come out of your image and manifest scan are maybe your Docker containers. And if you might also have SBOMs, which you use to give it to your customers so that they know what kind of dependencies you're using. And then what you also want to make sure is you're using the containers that you have built. That means the containers are not tampered or the SBOM file has not been tampered. So that is why signing is required. It validates that either of the images are not tampered. Now let's look at one small example that uses this. So I have a Docker file here. It is nothing fancy. It is basically having a Python image that and it is installing some dependencies from the requirement.txt and running it as a server. Now, what I am also doing is I'm deploying it through in a Kubernetes cluster, and I created a manifest file which ends up having some configurations. And I also have this behind a load balancer. I hope you folks are able to see. So the first thing I'm going to do is I have this Docker image already built. So I'm going to run a scan on this image. For this, I am using a tool called Trivi. It is an open source tool that is available, and you can incorporate this as part of your build pipeline itself. So what Trivi gives me is it gives me the particular library that is vulnerable, the particular installed version, and if it is fixed. So there are low, medium, high, and critical types of risk. Normally, we end up fixing high or critical risks, but that is a good start. And once you have them fixed, you can end up moving to low and medium as well. Now, once this is fixed, we also mentioned that because we are deploying it in Kubernetes, we have a Kubernetes manifest file. I run the I run the Trivi scan on the manifest file as well. Takes a bit of time. What ends up happening is Trivi downloads all this content every time you run this, and then it scans the manifest against the known vulnerabilities and points them out. One way to avoid this is you can run it as a server as well, and you can have a bunch of clients talking to it so that you don't keep on downloading the content again and again. So now that Trivi has completed the scan, it has given me a bunch of vulnerabilities here. So one of them being, because I did not define proper resource limits on my CPU, there can be a DOS attack. If there's a DOS attack, then what the pods can end up consuming most of the CPU and causing a degradation to my service. So that is why this recommends adding CPU and CPU limits, as well as it is not recommended to run your containers or your pods as root. That is why it is also saying the security context, make sure the run as non-root is set to true. Awesome. Now this is done, I am going to push the Docker image to my Docker registry, right? The Docker image is already there in the registry. Next, what we have decided is we also need an SBOM so that we can give the SBOM dependency to our clients and they know what all dependencies that they are relying on. So for this, Docker itself has a command that Trivi itself has a command which generates an SBOM file Trivi itself generates an SBOM file. So when I run this command, it generates the file which has all the dependencies mentioned in it. We can see those content here. So for example, in my Docker image, I have all these dependencies listed. Good. Now we are complete with the second step where we have scanned the images and scanned the manifest as well. Now we are left with signing. In order to sign, there is also another open source tool called Cosign, which helps you sign your Docker images. So how Cosign works is you have a public key and a private key, and you sign your image with your private key and push it to the registry. And the public key is already available, which you distribute. And anyone using the image validates the image with the public key. So in this case, what I'm going to do is I'm going to sign the image with my private key, for which it's going to ask passtrace. So this is going to sign it with my private key. And then finally, what is going to happen is I'm going to run another command, which is called cosign verify, which is going to verify the authenticity of this image. So here I give the public key and I ask it to verify. So yeah, here you go. So it is able to verify the image with the signature and then able to tell you that this is a valid image provided by the particular private key. So we have completed distribution as well now. Coming to the last and final phase. Okay. So in the image scanning, there is one more section called hardening as well. With hardening, what ends up happening is you want to make sure the service inside your image, inside your container runs as non-root, and also minimal base images will help you reduce your vulnerabilities. For example, if you have to compile your app with JDK, but you don't have to run it with the JDK. So once you compile compile with your JDK, in the next image, you can just remove that and have the JRE runtime environment. So this is called minimal base images. It will help you drastically reduce the vulnerabilities. And then we have already discussed about the manifest scanning. Finally, what we have is runtime. While the development and distribution options, the security checkpoints are limited, with runtime, there are quite few options available. So that is why I think what I would recommend is starting with the configuration inventory itself. So when I say the configuration inventory, it is about, for example, if you have infrastructure components like your storage buckets or your Kubernetes clusters, it is important to understand what their current configuration is. For example, the reason being, if all the configuration was in the IAC, scanning the IAC would have been enough. But as the organization grows and there are more than 10, 15 teams, it is not mandatory that everybody deploys through IAC. Some might use REST APIs and some might end up using other tooling available. So what you as a company or what we as a company want is get the current configuration of our infrastructure resources and identify if there are any vulnerabilities. For example, with Azure, there is Azure Resource Graph Explorer that gives you that information. With AWS, there is something called AWS config that gives you all the audit trails or all the information that is available or going on in your AWS cloud resources. That what you can also do is you can end up writing policies. What I mean by policy is, for example, let's say you want to avoid using connection strings when talking to storage accounts or anything. You might want to use managed identity or AWS service accounts. So the only way you might end up knowing this information is from the current configuration in production, identify the particular attribute that is there. And if that particular attribute is set to true, that means the connection string or AWS connection string is being used. So with the policy, you can identify such things and ding the team saying, hey, I don't think this is the best convention. We should move away from this. So these are some of the security checkpoints that you can add to your build pipelines or your day-to-day SDLC so that when you ship your code or your infrastructure, it is more secure and reliable. Yeah. So to conclude, what we currently discussed was in development, we have threat modeling, static analysis, and code reviews that basically help you identify any misconfigurations on your dev box itself. Once that is done, you have the distribution phase, which helps you create secure artifacts that can actually be deployed to production. And once that is done, you have your runtime, which actually you can start with configuration, inventory, and policies, and then move on to security posture management and so on. With that, these are some of the tools I have used. These are open source. Trivi is used to scan images and configs. Chekhov is used to do code style check-in. And then Cosine is used for image mostly signing and stuff. With that, I conclude my talk. Thank you.